In the first two videos of this series, Visualizing Objects, we looked at the history of object-oriented programming and why using objects to create computer applications became so important. In this third video of the series, we are going to look at how one might go about finding objects that would be used to create functionality that satisfies the requirements of an application. Here is the definition of an object, which was given in Visualizing Objects 1. An object is a software construct which is composed of data in the form of variables and functionality that operates on that data. Now I am going to add two interpretations to that initial definition. The purpose of these interpretations is to help us in identifying objects of an application. First, a software construct with data and/or functionality that represents something conceptually identifiable in the problem or solution domain. 2, something one can hold in one's mind as a conceptual whole. Usually one will be able to name the something. We can only name things which we think of as a whole or complete concept. Note that we will consider the problem domain as the requirements phase of an application and the solution domain as the development phase of an application. Based on the interpretations of the previous slide, what should we be looking for as we proceed through development of an application? Generally, we are told to look for nouns and noun phrases in the requirements, gathering, and analysis phase. This approach will identify many potential objects, but may miss identifying other objects which are not initially found as nouns. Here is what one should keep in mind when finding potential or candidate objects of an application. First, tangible entities which will be found as nouns or noun phrases. Examples of these entities are things such as employee, customer, purchase order, receipts, or contract. Beyond this, one should look for functionality in the requirements, which are functional wholes. That is, some functionality which has a well-defined beginning and end. Some examples of this might be a process, such as an order fulfillment, or a description of a workflow, or functionality which is cohesive. We will see an example of cohesive functionality becoming an object later in this video. Finally, there are concepts which will often be abstract, that is, not represented by a real-world entity. Software concepts such as collections and strings are one example of this type. One might also find adjectives indicating data or functionality, often described by verbs, which indicate the need for a containing object. Objects identified through the second and third of these suggestions will be objectified and given a name, and therefore become a noun within the design and implementation process. Where do we look for objects in an application? Well, there are two phases and there are two domains. These are essentially describing the same application in different ways. So in the phases, we may look in the requirements gathering and the development of the application, and those phases will frequently overlap. And in the domains of an application, we might look into the problem domain or the solution domain. Typical problem domain objects from requirements might be customer, purchase order, product, service, part, employee, contract, business process, etc. And then typical solution domain objects in the development environment might be objects found in the development programming language, such as collections and strings, or solution objects, which are often unique to each solution domain. Here are some additional suggestions for finding objects in an application. We've talked about most of these, so I'm not going to read through this list. I'll just give you a few moments to look them over, and then we'll go to the next slide. Now I would like to take several example descriptions of initial requests for development of an application that a business may present to their software development team. These are nothing like what the final requirements might look like, but there is enough detail in these requests that we can identify potential objects of the final application. What you will see is the objects that I have identified from these brief descriptions. Someone else might identify a different list, but I believe there would be more similarities than differences between our lists. This first request is from a power company supplying electrical energy to its customers. A utility company's customer service department wishes to serve its customers better by making sure every customer request for maintenance is serviced in a timely manner, and the customer is notified of expected start and end times and any changes that occur in that schedule. In their current system, which relies on manual routing of requests from inception to completion, customers' requests sometimes get lost or shuffled to the bottom of the stack, resulting in slow turnaround time for that customer. They would like a new automated system that electronically routes customer orders and tracks their progress, reporting when an order exceeds certain estimated or pre-programmed time limits. Customer orders include new service, termination of old service, and repair of existing service. You are to design and write this application. In addition, the new system should track the schedule, availability, and location of maintenance personnel. Here is a first pass at identifying potential objects from the requirements and then culling that list for those objects which may become objects of the final application. You might ask why the potential domain object customer request was not on the final domain object list. A customer request is a request for service of some kind from the power company, so customer request in the potential list became service request in the domain object list. I am not going to go into my rationale for arriving at the domain objects list. I will just point out that both lists are retained as artifacts of the software development process, and the selections I have shown may change during that process. In addition, the potential object list includes words identifying possible properties of objects in the final application. Here we are not eliminating anything from further consideration. In this slide I have shown my significant objects of the final application. Objects found in the domain are shown circled in red, while objects found in the solution phase are circled in green. The point of this slide is to show objects that were not found in the problem domain but were identified in the solution domain. For example, I identified a schedule object in the previous slide. In further development of the application, it was found that a schedule should have tasks to complete and a timer object to track the progress of completing the schedule. I hope viewers are wondering why the task object doesn't have a timer also, or why the maintenance employee object doesn't include a schedule object. It certainly seems obvious that the maintenance employees should know their daily schedule. If you are wondering about these things, good. You're starting to think in an object-oriented way. And maybe task objects should have a timer so the power company maintenance department can monitor the average time required to complete a task so that the scheduling of a task start and end time will be more accurate. Or perhaps the timer in the schedule object can perform the monitoring of the time taken to complete a particular task. You can see that there are many interesting decisions yet to be made as to which responsibilities or functionality will be assigned to which objects, shown in the objects proposed for creating the final application. These are all very interesting questions, and you probably will frequently be asking yourself how, for any particular object, can that object be designed and used within the application to achieve maximum independence, or put another way, minimum coupling to other objects of the application. Why did I just bring up this question of coupling? Well, because we were just talking about where the timer object might be put, or how the employee object might usefully contain a schedule object. All of these decisions are part of creating an application with minimum coupling. Reducing coupling improves the maintainability of your application and may even lead to reuse possibilities. A word about coupling. Coupling in an application can be observed when a change in the implementation of one class affects other classes. If more than a few classes are affected, look for ways, usually a design change, to reduce that coupling. The tightest coupling is between a subclass and its superclass. If the superclass has instances and a change in it requires change to the subclass, consider making the superclass abstract. An abstract class cannot be instantiated. And add a subclass where the changes can be made. The new subclass will have the superclass name, and the superclass will be renamed to its class name followed by abstract. As a general rule, all superclasses should be abstract, except in cases of well-developed class hierarchies, as for example those which are included with the programming language being used. I'd like to make a few final comments. First, there is no easy and fast rules for finding objects in an application. Nouns and entities are a good start, but there will be many more than these needed for creating a good object-oriented application. There is no one right set of objects for an application implementation. Two applications created from the same set of requirements may have many differences in the objects within each application. However, there will probably be more similarities with the objects than there are differences. Don't start creating your hierarchies until you have identified the domain objects of the application. At that point, hierarchies you create are more likely to be stable. And last but not least, as the idea of reuse is often overhyped, do not attempt to develop for reuse. Reuse will happen if the objects of the application are independent. That is, if the coupling between objects of the application is minimized.